With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? That there is a hydrogen-like neutral species in some excited state A. Now, on absorbing a photon of energy 3.066, it gets excited to new state B. Now, when the electron from state B returns back, photons of maximum 10 different wavelengths, okay, maximum 10 different wavelengths can be observed, in which some photons are of energy smaller than 3.066, some have equal energy, and only 4 photons have the same, have energy greater than 3.066 electron volts. Okay, now ionization energy of this atom would be, we need to find what is the ionization energy of this atom. How can we do this? Okay, so there are 10 different wavelengths which would be forming. That means there would be 10 transition. So we know that if there are n excited state, then n into n minus 1 divided by 2, these would be corresponding to the different wavelength, because this would be corresponding to the transition. How many transition? N minus 1 divided by 2, from n to 1, these number of transitions. So correspondingly there would be this many number of wavelengths. So in this condition we are getting 10 wavelengths, so we can just substitute it to 10. Okay, so it would be n square minus n, and then it would be 20, and if we bring to this side of itself, so it would be minus 20. This is equals to 0. So this is basically a quadratic equation. We can just solve it by factorization. So we can just write it n square, then minus 5n plus 4n minus 20 equals to 0, or if we take n to be common, so it would be n minus 5 plus 4, n minus 5 equals to 0. So our n value would turn out to be 5 or minus 4. Now number of excited state cannot be negative, so we can say that our the maximum excited state would be equals to 5. Now what would be, so the transition was from A to B. Okay, now A was already an excited state. That means our first n1 would be equals to 2. Okay, because n equals to 1 is the ground state. Okay, now what would be B? B would be this n2 in this condition would be our final excited state, which is equals to 5. Okay, that means the transition is from A to B, that means 2 to 5 in the first case. Now when electron goes from this to this, when the excited state is from n equals to 2 to n equals to 5, so the energy absorbed is given as to be 3.066 eV. So what we can say, that energy in nth state would be given as minus 13.6 z square divided by n square. We can just take this factor to be as equals to k. So we can say that it would be k then z square divided by k z square divided by n square. Okay, now whenever there is a transition, so we can say that the difference of the two states would be the energy which is absorbed or which is released. So we can say that En minus, so this is from n equals to 1 to n equals to 2. So we can say that En1 minus En2. This would be the energy which is released. Okay, from n equals to 2 to n equals to 5, energy is 3.066. So we can put the value of n1 and n2 into our energy expression. So it would be k z square divided by 2 square would be 4 minus k z square divided by n2 value is 5. 5 square would be 25. This would be equals to 3.066. So if we take the LCM and if we solve this, so it would turn out to be 21 divided by 100 k z square. So this value would be 3.066. So we can say that our kz square value, this would be equals to 14.6. Okay, this is the value. Now what have been asked? We have been asked about the ionization energy. Ionization energy means what? It means that transition would be from our first excited state to, we can say that our n1 would be equals to 1. That means from the ground state. And what would be n2? N2 would be infinity. Okay, this would be the case, because we need to make the electron eject from the this orbit. So n2 would be infinity. So what is the energy? So we can say that En minus En1 minus En2. This would be our IP, ionization potential. So it would be k z square divided by 1 minus k z square divided by infinity square. Infinity square would be equals to 0. 1 divided by infinity square would be 0. So it would be just kz square, which value is 14.6. Okay, so it would be 14.6 electron volts. So which option is the correct option? Our A option is the correct option, 14.6 eV. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.